Hello everyone! In this video, we will solve an example of the introduction and the basic concepts of thermodynamics and heat transfer. A 5 kg rock is thrown upward with a force of 150 Newton at a location where the local gravitational acceleration is 9.79 meter per second squared. Determine the acceleration of the rock in meter per second squared. So first, let's identify the given in our problem. So we have 5 kg as the mass of our rock. We have 150 Newton as the force acting upward on the rock. And we have here 9.79 meter per second squared as our acceleration due to gravity. So the problem tells us to find the acceleration of the rock in meter per second squared. So take a look on our diagram. So we have here the forces acting on our rock. We have the upward force, 150 Newton, and the downward force, which is the weight of the rock, and it is unknown. Since in the problem, we have the given mass and the acceleration due to gravity. So we can now solve the weight of our rock. Given the equation, weight is equals to mass times acceleration due to gravity. So plugging the given values, we have 5 kg multiplied by 9.79 meter per second squared. So calculating this, we will have now the weight of the rock, which is 48.95 Newton. So now, since we have now the value of our weight, which is acting downward of the rock, we will now solve the total net force of all the forces acting on the rock. So based on our diagram, we only have the vertical forces. So we will now have the summation of the forces acting on the vertical direction. We will assume the forces acting upward is positive. So we have now the upward force minus the downward force. So plugging in the values, we have the upward force, which is 150 Newton, minus the downward force, which is the weight, which is equal to 48.95 Newton. So we have now the total net force acting on the rock, which is equal to 101.05 Newton. So we have now the total net force of our rock, and we have now the mass of our rock, which is given in the problem. So we can now solve the acceleration of the rock using the equation of the force, which is force is equals to mass over acceleration. So deriving the acceleration formula from the force equation, we will have acceleration is equal to force over mass. So plugging the values in the equation, we will have 101.05 kg meter per second squared, or Newton, all over 5 kg. So plugging in the calculator, we will have now the 20.21 meter per second squared as our acceleration of the rock.